Hello, welcome to another class on the R language primer. Today we'll look at matrices, which are a fundamental building block for both mathematics and for data manipulation. I assume you have read all our earlier lessons and very comfortable with them, and we'll now move on to this session. A matrix is a data structure where you arrange the data in a tabular form, which we call as a two-dimensional rectangular layout. You'll have rows and columns, something like you would see in a spreadsheet or where you would write down, let's say, names of cities on one side and the distance on the other side and so on, rows and columns. The other important thing is the elements have to be of the same type. They should be of the same atomic type, means they all have to be of the same type of data. And of course they are useful in calculations. The syntax for creating a matrix is use the function matrix and we specify the following. The first option is data, where we give the vector which contains the elements of, or rather the contents of the matrix. N row refers to the number of rows in the matrix and an N column refers to the number of columns in the matrix. By row can either be true or false. If we specify by row equals true, then the data will be arranged row by row. If it is omitted or if it is false, the data will be arranged column by column. Dim names is the names assigned to the rows and columns. We can, just like we did in the earlier chapter, we can name the rows and the columns. For example, we have a program which creates the matrix and then displays them. We have the first line, of course, is a comment. Second line is also a comment. It's the third line where we specify a matrix where we are generating the numbers between 1 and 12, specifying the number of rows to be 4. And in this example, obviously the columns will become 3 because we have 12 elements. And we want the data to be filled up row-wise. So we said by row equal true. Then we print the matrix. Now we create a second matrix with the same number of cells, that's the 12 cells containing the values 1 to 12. We have 4 rows where the columns is 3. But since the by row has been specified as false, the data will be filled up column wise. So we print that also to see how the data comes. Then we are assigning names to the rows and the columns. The row names are row 1, row 2, etc. The column names are column 1, column 2, etc. And then in third matrix, we're still generating the same 12 elements 1 to 12, values 1 to 12. 4 rows means 3 columns, by row is true. And then we are also naming the rows and the columns, which are specified in the row names and column names definition. Then we print the matrix. The output would be, since the first matrix was row wise, it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, reading row wise. Since the second matrix was column wise, we will get 1, 2, 3, 4, 5, 6, 7, 8 column wise. And in the third case, we still have the row wise, so we still see the 1, 2, 3, 4, 5, 6. But instead of numerical values for the rows and columns, we see the names we have assigned, which is row 1, row 2, row 3, and so on, and column 1, column 2, column 3. You can see the program in the upper window where it's the same example we have seen on the slide. And you can see the output generated by the R Studio, which is there in the box in the lower window. Now we go to accessing the elements or the individual values in the array by specifying the row and column index numbers. So we have an example where we have the row names, row 1, 2, row 1, row 2, column names, column 1, column 2, etc. We create the matrix, which is 12 values 1 to 12, row wise, since the by row is true. And then we also access the elements as follows. When we say print mat1, which is our matrix, 1, 3 is the first row and the third column. The next print, which is 4, 2 is the fourth row, second column. If we specify only the first index or the first subscript, we get the entire row. It is 2, print mat1 box brackets 2, prints the entire second row. And if we omit the row and specify only the column, we get the entire column. Whereas in the last example we have print mat1, we have omitted the row, we just put a comma and we put a 3. So the third column is printed. The output would be, we can see the output there, we see 3 as one element, 11 as another element. We see the entire row which is specified, and we see the entire columns. We run this same example in RStudio. You could see the program in the upper window and the output in the lower window. So you could compare the output of each line in the program with the actual output shown in the window below. Matrices can also be operated upon arithmetically, and we are now looking at some of the operations like add, subtract, multiply and divide. So we have created the matrix, a 2 by 3 matrix, and we have created another matrix. In both cases we have said the number of rows is 2. Then the plus sign, when we say add the matrices, we use the plus operator to add matrix 1 and matrix 2. And as all of us know, in the matrix addition, the elements will be summed on a 1-to-1 basis, corresponding positions 1-to-1 basis. Then we subtract the matrices, where we say M1 minus M2. The operator minus will subtract the corresponding elements of the second matrix from the corresponding elements of the first matrix. So we have the output where we talk about, where you can see the two tables, the two matrices. You can see the sum. If you look at matrix 1, 1, 1 it is 2, 1, 1 it is 6, so we get 8. So if you look at row 2, let's say column 2, the first matrix is 5. Row 2, column 2, the second matrix is 6, so we get 5 plus 6, which is 11. We also look at the subtraction, where matrix 2's values are subtracted from matrix 1's corresponding values. So we get this, for instance, we have 1, 1 in matrix 1, which is 2. We have 1, 1 in matrix 2, which is 6. So 2 minus 6 is minus 4, which is the result in the last matrix. You can see the program in the RStudio window, and the corresponding output appears in the window at the bottom. So we could also match them 1-to-1 for each command, what the output will be. Addition, subtraction, multiplication and division. So now we go to the multiplication, where we have similar examples, but the asterisk sign is used for the matrix multiplication and the slash is used for the matrix division. Same rules apply, it's corresponding 1-to-1. So we have the 2, 5 minus 6 on the first row, first matrix, 6, 1, 0 on the first row, second matrix. So we have 2 into 6, which is 1, 1 of the first matrix and 1, 1 of the second matrix, which is 12. Let's say we take 1, 3 of the first matrix and 1, 3 of the second matrix, which is minus 6 into 0, which is a 0. The division, the last output, there's a division, where we can see that if we take the division 1, 1 of the first matrix, which is 2, and 1, 1 of the second matrix, which is 6, so we'll get 2 by 6, which is 1/3, and so we'll get the 0.333. And if you go to this 1, 3 in the output matrix, we see the letters INF, which stands for infinity. So let's see what the example is. So we have 1, 3, which is minus 6. We have the first matrix, and 1, 3, which is 0 in the second matrix. And when we divide the minus 6 by 0, our answer is infinity. You can see the program in the window at the top in the RStudio. You can go line by line. You could see the output of the first matrix, second matrix, the multiplied matrix and the divided matrix. We thank you for listening to us. If you have any doubts, please do refer to us at the email address given below. We look forward to hearing from you. Trust yourself. You know more than you think you do. Have a great day.